Hello students, welcome to our class. This lesson we will learn the knowledge of high voltage interlock fault diagnosis and elimination. A pure electric vehicle cannot be powered on with high voltage. Find a high voltage interlocking fault after using the decoder for detection. As a professional technical maintenance personnel, please solve this problem. The catalog of this course is divided into 3 categories. 1. Understand the high voltage interlock. 2. Master the principle of high voltage interlocking. 3. Master the fault diagnosis of high voltage interlocking. Overview of high voltage interlocking. 1. High voltage interlock. According to the national standard, the DC voltage exceeding 60 V and the AC voltage exceeding to 5 V is defined as high voltage. Therefore, according to the provisions of the ISO 6469 International Standard, the connector of the high voltage parts of electric vehicles should have a high voltage interlock device. 2. High voltage interlock position. According to international standards, the high voltage interlock device of high voltage components on electric vehicles is generally installed inside the high voltage connector. 3. Definition of high voltage interlocking. High voltage interlock, HVIL, is a safety design function to monitor the integrity of high voltage loop with low voltage signal. The battery management system, BMS, and the vehicle controller VCU send a low-level signal to all the high-voltage harness plug interlock lines back to the BMS and VCU respectively, and the integrity of the high-voltage line is confirmed by the return signal. 4. The role of high-pressure interlocking. If the signal is abnormal, the BMS and VCU will default that the high-pressure plug of the vehicle is artificially pulled out or the plug is not strong. In order to avoid dangerous situations, the BMS will give the following feedback according to the status of the vehicle. 1. Failure warning. As long as the high-voltage interlock signal is missing, whether the car is stationary or running, the instrument alarms and sends an alarm sound. 2. High voltage cutoff. The high voltage interlocking signal is missing and the vehicle is stationary. 3. Reduced power operation. The high voltage interlock signal is missing. The vehicle is in the process of high-speed driving, reducing power operation to ensure that the driver stops the car in a safe position. 5. Classification of high-pressure interlocking. 1. Structural interlocking. The high-voltage connectors of each high-voltage component are connected in series by the high-voltage interlock wire harness, and the integrity of the high-voltage system can be guaranteed only when the connector is installed in place. 2. Functional interlocking. On the principle of charging first, that is, when the charging gun is inserted, the vehicle cannot be powered on, but the air conditioning system can be used, such as compressor refrigeration, PTC heating. 3. Software interlocking. You need technology. By judging that the rear-end bus voltage of the high-voltage connector is lower than 1 divided by 2 of the total battery voltage, the interlocking fault. The high-voltage components involved in software interlocking are power battery, PTC, and electric compressor. High voltage interlock principle. 1. High voltage connector. Structural composition of the high pressure connector. The high voltage connector with high voltage interlock function consists of shell, high voltage conductor, low voltage signal conductor, monitor and monitoring line. The general structure of the high voltage connectors is a pair of male and female heads, respectively fixed with a pair of high voltage connectors and a pair of low-voltage connectors. 2. High-pressure interlock terminal. The high-voltage interlock structure is included in the connector through the difference between the interlock terminal and the terminal of the main high-voltage loop. Connect the high-voltage terminal first, and then the high-voltage terminal. 3. Overview. The interlocking monitoring circuit of Geely-Embrand E.V. 450 consists of two parts: the high-voltage interlocking monitoring circuit of the main circuit and the internal interlocking monitoring circuit of the high-voltage battery. They communicate through the CON network between the body control module and the battery management system. 4. The interlocking signal is a square wave signal with an amplitude of 12 volts. 5. High-voltage interlock signal transmission route. 1. The transmitting and receiving paths of the main loop interlock signals are: the vehicle control module issues, the motor control module, vehicle charger, air conditioning compressor, heating controller back to the vehicle control module. To the transmitting and receiving path of the battery is: the battery management system passes through the high voltage bus interface and the DC fast charging interface. 6. Common types of high voltage interlock detection in real vehicles. 1. Check the vehicle high voltage circuit through the low voltage interlock wire harness in the controller. To the end cover of the controller is arranged with an open cover detection device, which can also detect the high voltage circuit of the vehicle. High voltage interlock fault diagnosis. 1. Use the scan tool to read the fault code. According to the working principle of Geely EV450 vehicle interlock monitoring system, its monitoring of high voltage line interlock is a large range measurement, and the accurate location confirmation of the specific interlock fault needs to be completed by professional maintenance personnel. Fault code is P1C for 096 high voltage interlock fault, P1C8, E0 for high voltage interlock PWM output signal open circuit. 2. Measure the main loop interlocking signal using an oscilloscope. Check the Geely Emgren EV450 interlocking circuit diagram for the following tests. 1. Insert the probe back into the terminal of the body control module CA67 divided by 76 and adjust the base and unit voltage values to display the waveform of the communication circuit on the oscilloscope. Record the time base value of the ordinate, the voltage value of the ordinate. To draw the measured waveform in proportion, and compare the standard high-pressure interlocking waveform to determine whether the signal waveform is normal. In this course, we mainly understand the basic knowledge of high-voltage interlock system, learn the principle of high-voltage interlock system, and get familiar with the common faults of high-voltage interlock system. I hope you can review and consolidate by yourself after class. Thank you.